a respiratory alkalosis. You could have a metabolic alkalosis. You could have a respiratory acidosis or a metabolic acidosis, and you go about figuring it out the exact same way. Okay? One step at a time. What would that do if that was the only factor, and that's what we found? Okay? And then you just decide, well, what's the other one doing? Is the other one going out of its normal ranges and doing exactly opposite of what the problem is? If so, it's trying to fix the problem, so it's compensating. If not, it's not. Okay? So let me give you another numbers here. We're going to go ahead and do pH of 7.30. That's a 7. We're going to give you a CO2 of 25 and a bicarb of 8. Okay. First question, always pH. Okay? Based on that pH, do I have an acidosis or an alkalosis?
Acidosis.
Okay, so we're all good. We have an acidosis. I can write that down because I know that's true. pH is the pH. First part of my answer, I already know it. Okay? Check that off the list. And then I write my little acid next to it so I don't forget. All right? My CO2 level is 25. If my CO2 level is 25, what is that in and itself going to do to my blood?
Yeah, it's explosive.
Yeah, exactly. It's going to make my blood basic because, or alkalotic, whichever we want to say, right? Is that the problem? It can't be a problem because it's doing exactly opposite, right? So let's stick a pin in that and go on to bicarb. My bicarb is 8. If my bicarb is 8 and bicarb is base, what is that going to do to my blood?
It's going to become more acidic.
I don't have enough base, therefore that would make my blood acidic. Yes?
Yes.
So, back to Sesame Street. One of these things is not like the other, right? Literally, match up the two that say the same thing.
So acid. So
that is acid.
acidosis.
Therefore, I have an acidosis, and it's caused by the bicarb, which is our metabolic side.
So
Yes.
respiratory
So
compensation.
therefore, I have a metabolic acidosis. Now we can go back and look at that CO2 that argued it was different. Is it compensating? Is it trying to fix the problem by doing exactly opposite of what the problem is?
It looks
I say yay, yay,
Yeah.
right? Therefore, we have a compensated metabolic acidosis. Any questions on that? Okay, yes?
So you're saying each time a bicarb is like jacked up, you would think it's something that's metabolic.
I would say yes. I would say bicarb is controlled by the metabolic system. So yes, anytime bicarb, to use your technical term, is jacked up, it is a metabolic issue. Whether it's fixing something or is a problem is a different question. But that's what I'm saying. Link in your head bicarb with metabolic. Link in your head respiratory with CO2. Yes.
If the CO2 was high, also making it acidic, how do you choose between metabolic or respiratory?
That is a good question, which is why I'm not going to do that to you guys in this class. Because if they're both going the same way, causing the same problem, then yes, that does happen. Because maybe, maybe somebody had a traumatic brain injury, and that traumatic brain injury made it so that they couldn't breathe, and therefore they would have a respiratory acidosis, but that same medulla oblongata was damaged, and therefore the chemoreceptors are not notifying the kidney about anything, and therefore it's not doing its job either. So it could happen.
Does the anion gap have anything to do with that?
Moving on
Okay.
to the anion gap. Yeah, so we'll do that in a minute. Yeah, what do you got?
Sorry.
Sorry, okay, so I know you said we don't have to know, like, or just even know them, so are you gonna ask us, like, could that be a potential question, like, if they're different, and then knowing, like, what it is based off the normal ones? That makes sense.
I have absolutely no idea what you mean.
So, like, the examples we just did, do we know how to do those for exams? Okay.
Yes, absolutely.
Okay.
Yes,
So, if something's compensated, so like in this example.
Natalie, can you hear her?
I can.
Exactly.
I can hear her.
I don't care if you can hear her, you can go, they can hear her way in the back.
If something's compensated, it just means that, say like in this specific example, the CO2 was a lot lower. So, is that why it's compensated? I'm kind of unclear on
Yeah, here's the thing. I don't know if you noticed or not. Go back and watch her video if she posts it. But I went way out of my way to try to not say lower or higher for that reason. Because once you start thinking in terms of lower or higher, things can get turned around real fast. What I try to say is that if it is outside of its normal range, and you look at that particular number on that gas or whatever, what will that do? Because if you start saying, well, okay, if it's lower, then you're gonna get messed up, okay? Because sometimes it will be outside of its range, depending on what we're talking about, lower, and it'll cause an acid problem, and sometimes it'll be outside of its normal range and it'll be lower and it'll cause a base problem. Or it might be trying to fix it. And that just gets confusing. So what I'm trying to say is that to go outside of your normal range, whichever way it goes and whatever it is, goes outside of its normal range, it's going outside of its normal range for two reasons. It's either causing a problem or it's trying to fix a problem. And we have to evaluate each one of these things individually to find out what it's doing.
So if it was within the normal range, then it would not be compensated.
Exactly. If in this exact same scenario, keeping it, it's a metabolic acidosis. If I took that CO2 and made it 35, we would call that an uncompensated metabolic acidosis because it's not trying to fix the problem.
So 2 hours is different than it's compensated. Just trying to ask compensated, right? Not doing the opposite. 'Cause you
Yes,
told
I
us to
think you
look
guys
at-
are saying the same thing.
Cause you told us to look at the two that are the functional, and if one is different in the normal range, it's
Mhm.
compensated.
Yeah,
Yeah.
yeah. Okay? Questions on that? I'm kind of out of room to make another example.
Yeah, we should do another example.
So, let's move on a little bit. Again, let me know if you have any issues. Okay, this whole thing right here is acid-base balance, right? It's like the other one was, but it has a lot more details, okay? The only thing I talked about on this whole thing is this right here. Why? Because it is the most important in extracellular fluid is that whole carbonic acid bicarbonate buffer system, which is that formula, right? That chemical formula. That's all we talked about. That other stuff, yeah, it happens, but you don't care. that's like way down the line. Gotta get this nailed down, and then someday you might wanna talk about that. I don't know. Depends on where you go in your life, okay? All right, this again, I don't think says anything different, does it? Bicarbonate, that's our normal values. Buffer, blah, blah, blah. Lungs, kidneys, nope, nothing new. Except this, and you don't need to know that. 20-to-1 ratio, who cares? Okay? This is for some of you nerds that really